Welcome to the deep dive. We're going beyond Bitcoin today, really digging into blockchain technology itself.
Right. There's so much hype, but the core tech, well, some experts are saying it's as big as the internet was.
That's a huge claim. So we've looked at the fundamentals, its potential, the whole decentralized idea, and yeah, also the challenges. Let's start basic though. What is blockchain?
Okay, think of it like a digital ledger or a database, but the key things are it's spread out across many computers decentralized.
Not in one single place.
Exactly. And it's built to be transparent and really, really hard to tamper with, immutable. This whole concept really kicked off with Bitcoin back in, 2008? Satoshi Nakamoto.
Right, Nakamoto. Okay, so this shared secure notebook, how does it actually work, these blocks you hear about?
Yeah, so imagine each block is like a page in the shared notebook. It holds a list of transactions or data records, right?
Okay.
And it gets a timestamp. But critically, each new block, each new page also contains a cryptographic link, a hash to the page right before it.
A hash, like a fingerprint.
Precisely. A unique digital fingerprint for the data in that block. If you change anything in the block, even a comma.
The fingerprint changes completely.
Totally. And since the next block contains the previous block's fingerprint, any change breaks the chain. It becomes obvious something's been messed with.
Okay. That makes sense. It creates that chain of trust. What about security for, like, who owns what? The public and private keys.
Right, that's the cryptography part again. It uses something called asymmetric cryptography. You get two keys.
Okay.
A public key, think of that like your bank account number. You can share it so people can send you stuff.
Right.
And a private key, that's like your secret PIN or password. You never share that.
Yeah.
You use it to authorize transactions from your account.
So it proves it's you sending without showing your password.
Exactly. It creates a digital signature, secure ownership and authorization.
And this ledger isn't held by one bank. It's everywhere, a peer-to-peer network thing.
Yep. The ledger is copied across tons of computers nodes all over the world. They all talk to each other constantly to make sure their copies are identical.
So no central server.
Nope. Transactions go directly between users peer-to-peer. It's like using Google Docs with everyone editing live versus you having the only copy on your laptop.
But if there's no boss,
Yeah.
how do they all agree on which transactions are legit and in what order?
Good question. That's where consensus mechanisms come in. Ways for the network to agree without a central authority.
Like proof of work, Bitcoin's thing.
Yeah, that's one. It involves nodes solving really complex math puzzles, kind of computationally intensive. Another popular one is proof of stake,
Spake.
where participants lock up some of their own cryptocurrency, put skin in the game to get a chance to validate transactions. It's generally more energy efficient.
Okay, so you have these linked blocks, the fingerprint hashes, everyone has a copy, they agree on updates. What does that actually achieve? You said immutability and transparency earlier.
Right. Immutability means once a block is validated and added to that chain, changing it is, for all practical purposes, impossible. The cost and effort would be astronomical.
Because you'd have to redo all the following blocks on most of the computers.
Pretty much, yeah. And transparency on public blockchains anyway means anyone can view the transaction history. Your identity is usually pseudonymous, tied to your public key, not your name, but the flow of transactions is open.
So the big innovation is trust through technology. Instead of trusting a bank or a government, you trust the code in the network.
That's a great way to put it. Trust is distributed and enforced by the protocol itself. And this allows something really cool. Digital scarcity.
Scarcity.
For digital stuff.
Yeah. Before blockchain, digital things could be copied infinitely. Blockchain allows you to create unique digital assets that can be proven rare and owned, preventing that double spending problem. Like digital gold, almost.
Okay, I think I get the how. Now the so what. How does this change things beyond just tech circles? Finance seems obvious. For sure. Finance is a big one. It potentially gives people more direct control over their assets, cutting out intermediaries. There's also this idea of censorship resistance, though you absolutely must protect your private keys. Lose those, you lose everything.
Right. Responsibility shifts.
And things like Bitcoin, with its fixed supply programmed in, that's a whole new take on monetary policy compared to central banks.
But it's not just finance, right?
Yeah.
I've heard talk about other areas.
Oh, way beyond. Think about property titles. A secure, transparent digital land registry could cut down fraud massively.
Voting systems.
Potentially more secure and verifiable, yeah. Or tracking goods through a supply chain, proving something is authentic, tracing its origin. Even digital identity, giving users more control over their own data instead of companies holding it all.
That sounds huge. But it's not perfect yet, is it? What are the bumps in the road?
Definitely not perfect. Scalability is probably the biggest hurdle right now. Many blockchains can't handle the sheer volume of transactions Visa or MasterCard can, for example. Speed and cost can be issues.
And the energy use for proof of work.
That's been a major criticism, especially for Bitcoin, though newer systems like proof of stake are much better on that front. There's a ton of work going into solutions, though.
Like layer 2s.
Exactly. Things like the Lightning Network for Bitcoin or roll-ups for Ethereum. They handle transactions off the main chain to speed things up and lower costs, plus core upgrades like sharding, splitting the database.
Sounds like a balancing act.
It is often called the blockchain trilemma. Trying to get decentralization, security, and scalability all at once is really hard. You often have to make trade-offs.
So looking ahead, what's the ultimate vision if they solve these problems?
The vision is maybe blockchain becomes a foundational layer for the next internet, an internet of value or trust, a way to interact digitally, exchange value, verify information more transparently, more efficiently, maybe more fairly.
Like the internet changed information flow.
Kind of, yeah. But for trust and value. We're still super early, though. Usability needs work, regulation is still evolving, and connecting real-world data reliably, the Oracle problem is tricky.
Lots to overcome, but the potential is clear. All right, to wrap up, thinking about this core idea, trust built into the system, decentralization. What existing process or system out there do you think is just begging to be disrupted by this? Something for our listeners to chew on.
Good question to ponder.
Thanks for joining this deep dive.